What's going on, Rovers? It's Mr. Shalat back with another video. Today, we're going to be talking about measurement as we roll into Unit 3. Um, the first two lessons we're going to have are going to be balled into one today. We're going to be talking about the metric system and the US standard system units of measurement. Okay, so let me share out my screen. We have a couple PowerPoints today to go over. Um, Taking a look here. All right, let's blow this up. Okay, so talking about the metric system to start off. All right. A typical metric scale often uses 30 centimeters. All right. So a standard 12-inch ruler, okay, what we have here on the screen, all right, a regular ruler is 12 inches long. On the flip side of that, the numbers that we don't normally look at, but we're going to be spending some time in this class talking about centimeters and millimeters. All right. On the other side, you have 30 centimeters. So when you're looking at the ruler, okay, and I'll move my mouse over here, all the large numbers you see, okay, those are all centimeters. All right. And in between each of those, you have the smaller lines. Those are known as millimeters. And we'll spend some time today talking about those. All right. Oh, this is jumping all around here. Let's go back a slide. All right. So the millimeter is the smallest increment found on the metric scale. So what happens is in between the 0 and the 1 or the 1 and the 2, you're going to have a series of 10 lines, okay? 10 lines come across. So as you come across, the line that ends up in the middle is longer than the other lines. That line represents 5, okay? That is the midway point. So when we're looking at this ruler right now, halfway between 0 and 1, the longest line is 5 millimeters, okay? 5 millimeters. And once you count these out, we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, this being the ninth line. The 10th line will be a larger bold number, and that is known as a centimeter. Okay, now your typical standard ruler is going to have 30 of those on a 12-inch ruler. Okay, moving forward. The larger marker here they're talking about it on the next slide. It says the next larger marking on the metric scale is at 5 millimeters. Now, the reason they do that, the reason they have this longer line is so you can quickly count. All right. When you are looking at a measurement and your measurement lands over here on this side rather than in this space, it lands over here on the right. Okay. You don't have to physically come in and count 1, 2, 3, 4, 5, 6, 7. All right. If you know it lands right here, you can immediately start counting at that 5 mark. So the reason it's there is for you to visually be able to count things a little faster. You know that's the midway point. So from here, I would only have to count over 6, 7. I wouldn't have to count up to 5 because we already know that this line is 5. All right. That's why they have that longer line there. Indicates halfway between the 0 and the 1. The largest markings on the metric scale represent centimeters. Okay, that's this large bold 1 that we're currently looking at. These are the only marks that are actually numbered. Okay, so on your ruler that you're looking at, all right, you're going to have 1 probably up to 30. Those are the only numbers that appear. They don't designate and put numbers down here for the millimeters. They only do that for centimeters on your standard scale. Okay, so what they are asking you to do here, and I'm going to have you pause the video in just a second. I'll say when. All right. They're going to give you a ruler here and they'll show you a box and they want to know how long is this box. All right. So when I click forward here, they blow this up into a larger view. Now, what I would like you to do is pause the video and somewhere on a scrap piece of paper, nowhere specific, I would like you to write down how long this rectangle is. However, don't pause it just yet. Don't pause it just yet. I want you to understand where this is landing. Okay, so based off of the information that you already have, go ahead and pause now and write your answer down. All right, now that you've paused and written an answer down, let's talk about what you're looking at. All right, so this long rectangle that they have here, it lands between the 3 and the 4. All right, so when we are writing our measurement down, okay, it's going to be 3 point something. It's not 4 because it never got to 4. This rectangle never met and went the full length. Okay, so it stopped somewhere. So where is this box stopping? As we take a look, it lands right about here. Okay, so if we start counting, we know that this is 5, 6, 7, 8. So 3.8. Okay, if you wrote down 3.8, you are correct based off of what we've talked about so far. However, every measurement that you take will have significant digits. Okay, a significant digits are non-arguable. They are definitely the answer. Okay, so when we look at this, we know that it is 3.8 because that is where the box is landing. However, this box does not land directly on one of these lines. So it is not exactly 3.8. It's 3.8 something. The 3 and the 8 are your significant digits. Those you can't argue. That we know that's how big the box is. But what the uncertainty, the last number that you're going to record, okay? That uncertainty, that last number you record, there will be a little bit of variance. So between you and other students in the class, you might be plus or minus 1 of what we think the answer is. Now, what you have to understand is you have to pretend that in between each of these two lines, okay, this being 3.8 and this being 3.9, you have to imagine that there are 9 little lines in between there. Okay, just like there's 9 lines between the 3 and the 4, there's actually, you got to pretend that there's 9 little lines in between there. Now, if it is closest to this line, it might be a 0, 1, or 2. If it's closest to the other line, it might be a 7, 8, or 9. And if you feel it's in the middle, okay, that would probably be a 4, 5, or 6. So depending on where this is landing, okay, visually just looking at it, we bring it down. All right. I would say this where this is landing, I'd say that's probably a 3 or a 4, okay, based off of how big that is. So our overall measurement when we're writing this down would be 3.8, 3 or 3.84. Those would be the measurements that I would write down if I'm measuring out how big this box is. Okay. So we'll go to the next slide here. They blow it up even more. Okay, so they want to know how long this is. You have to imagine that there are those little lines that are running in between there. Okay, this being 1, this being 9. You got to pretend that there's 9 lines in between there. All right. So they'll draw some arrows here. Make sure they're not putting anything behind my picture. Let's move this up. Okay. So how long is the decimal scale instrument? Record all the digits that are certainly determined from the scale markings and estimate one more digit. Okay. So we are certain of the 3.8. That last one, there's going to be some variance, right? So they are telling us our answer should have been 3.84. And prior to this, I said it would be 3.83 or 3.84, depending. All right. That's why I said anyone that wrote down 3 or even 5, okay, plus or minus 1 there would be an acceptable answer. Okay. But 3.8 are non-negotiable. Those are significant digits. Those are digits that everyone will have the same answer for. It's that final digit, the one that you are uncertain about. Okay, that's where we are going to have some differences in our between you and your classmates, and that's okay. All right. So here they're giving us another one. Let's take a look at it. Okay. So we'll let that blow up. And at this point, I would like you to pause the video, figure out how long this rectangle is. Okay, now that you've unpaused, we'll discuss it. All right. We take a look at this rectangle. It's coming between 6 and 7, so it's going to be 6 point something. We start counting lines over. That's 1, 2, 3, 6.3. And then what is that uncertain digit that we're going to record? This is fairly close to where the line is at. I would probably say it's a 1, which means if you wrote down 0 or 2, you're going to be good. Let's see what they say the answer is. They're saying it's 3. Okay, so we're fine. All right, we're all within 1 or 2 digits. Things are good on this particular one. All right, and again, if you zoom in, okay, you put your face closer to the screen, you might say, oh, that's a 2, that's a 3. I said it was a 1. Okay, as long as you're within a digit or two, you're going to be in good shape. But those first 2 digits are non-negotiable. Okay, that's 6.3. All right. Now, what they're showing you here, all right, they want you to do the same thing we just did, and they want to know how long each of these boxes are. Okay. Now, this is actually in the packet for today. So if we take a look at the Word document, and I will share that out so we can take a look. Okay, so in the Word document that you have that you're going to be working on, as I scroll down, it's the same exact picture that was over there in the slideshow. Okay, using the same process, you are going to determine how long is box A, how long is box B, how long is C, so on and so forth. And you're going to fill that in on the chart. Okay, now when we are recording our numbers, you've got to make sure you record the units. So all of these will be in centimeters. You're recording everything in centimeters. So you will have a series of numbers here, okay? And those numbers will be 2 significant digits plus 1 variable. So you should be writing 3 numbers down for every single one of these answers, okay? Every single one, it'll be 1.2, and then you don't know what the other number is. So for every single one, you're writing 3 digits down. You're going to fill in this chart here, okay? Coming down to 6 and 7, they ask you to take the measurements that you got above and then subtract the difference, okay? Please make sure you show your work when you're putting those answers down here for 6 and 7. Number 8, okay? They want you to measure out the box, okay? How big is this? So you will measure from one side to the other, okay? And figure out all of these dimensions. Now, on here, they want to know the radius. So the radius is actually from here to this center point, or from this center point to here. Please do not measure along that line, okay? So this here where they're asking you the radius, you're going to record that there in centimeters, okay? How far is that distance? Over here, they want to know the diameter of the circle. So that circle with the slash through it, that's the symbol for diameter. They want to know what is the diameter of that circle. When you're working on this document on your iPad, which is where you'll end up measuring, okay, please make sure your scale when you're looking at this document is at 100%. Okay, don't be zoomed in on the document. Don't be zoomed out. Should be looking at the document at 100%. All right, then it's going to ask you to take your ruler and they want you to measure some random objects around your room. It can be around the classroom or around your house. Okay, they want to know what is the object and what is the description of the measurement that you are taking. Okay, so for instance, what is the object? Okay, I hold up my cell phone. Okay, my object would be an iPhone. Okay, the description of the measurement would be the height of the iPhone, the width of the iPhone. These are measurements that you would take. Okay, the description is telling me what is the measurement. Don't just write down iPhone. We need to know what measurement you're taking on the iPhone. The units that you're recording, okay, those are all going to be in centimeters. Okay, so make sure you're recording everything in centimeters. And then over here on the right is where you're going to record your Actual numbers, the numbers that you get from measuring with your ruler. Scrolling down, says in your engineering notebook, create a full-scale isometric of the object represented in the following sketch. Using the dimensions shown, okay, use a metric ruler to obtain the correct dimensions of the sketch. So what I want you to do is you're going to use ISO paper, okay, the paper that goes back on 30-degree lines. You are going to draw this object, but you're not going to count boxes. So when it goes back to the left, it's saying go back 3.5 centimeters. You're going to put your ruler on there and count out 3.5 centimeters and draw this exact. This line needs to be 3.5 centimeters. When you're going back to the right, it says the depth is 2. You're going to make sure your depth is 2 centimeters. You're not counting boxes. You're using actual measurements. So use your ruler, all right, and count out the number of centimeters. We're going to switch over now to our other PowerPoint. Let me stop sharing this. We're going to take a look at the US scale now. So we'll bring up the PowerPoint. We need to stop sharing this. How do we do that? How can I get out of this? All right, let's try it again. So we are going to share. There we go. We'll go full screen. It's showing me the wrong one. All right, now we're good. Now we are good. All right, let's blow this up a little bit. Let's talk about it. Okay. Your standard 12-inch ruler. Okay. Standard 12-inch ruler. The large bold numbers that you see on the ruler are your inches. Okay. A typical ruler is broken down into 1/16 of an inch. To me, this is the most important lesson that you take away from this class, okay? Because there are going to be times where you need to measure things and then go to Home Depot or whatever and buy things. You need to know how to read a tape measure. So some of you right now do not know how to read a ruler. By the end of this lesson, you should understand how to read a ruler because no one has ever explained it to you. This is super important. This is a life lesson. So if you don't know how to read a ruler, this is what you're learning right now. Okay. My goal is by the end of this PowerPoint here, I will have it fully explained and you will understand how to read a ruler and a tape measure. All right. So let's take a look. I'm going to size me down. There we go. All right. It says the divisions of a customary scale are easily identified by different size marking. The largest marking is known as an inch. That's what we just talked about, the large bold numbers that you see running across. You have to pretend that the left-hand side here is the 0, the right-hand side is the 1-inch mark. All right. In between the halfway point from here to here, okay, the halfway point, you will have what is the longest line. We just talked about the longest line in metric is 5 millimeters. All right. Well, now you're going to have 16 lines that run across the ruler, 16 individual lines that run across. Okay. Every time you cut a measurement in half, you're going to double the bottom number. Okay. Every single time. So we start off with a half because this is halfway. How do we get a half? There are 16 lines, okay? The eighth line over 16, 8/16. 8/16 reduced is 1/2. So that midway point, that center line, that's going to be your longest line, is 1/2. It's the midway point from 0 to 1. It's a half. How you got a half is because it's 8/16. If we want to take half of a half, so we have a half and we want to cut the half in half, you double the bottom number. So in this scenario, you have 1/2. So the 2 doubles, okay? And that becomes 1/4. So halfway between 0 and a half is a quarter, okay? You have split this distance in half. You end up doubling the bottom number. In this case, it's 1/4. Okay. Well, 1/4, if we had all the lines on the ruler, this actually ends up being the fourth line over 16. Okay. So there's 16 lines there. And in a minute here, you're going to see all those lines. The fourth line out of 16 reduced is a quarter. Okay. 1/4. So every time you're splitting this in half. Now, every time you see a line that is the same length as the quarter, as we come across, there ends up being one more. That will be an odd number. Okay. We're always going to use the odd numbers. And in this scenario, we have 1/4 and 3/4. Okay. 3/4 is actually the 12th line out of 16. 12/16 reduced is 3/4. Now we're going to take our quarter and we're going to split that in half. So if I take 1/4 of an inch and I cut it in half, you get 1/8 of an inch. Okay, so you double the 4, it becomes an 8. Now again, we use the odd numbers we come across. We're at 1, 3, 5, 7. Okay, always odd numbers. 1, 3, 5, 7. It's 1/8 of an inch. Okay, on the ruler, once we have all of our little marks here, okay, it ends up being 2/16. 2/16 reduced is 1/8. So every time you're taking one of these lines, you're cutting it in half. So we started with a half. We cut that in half. We got a quarter. Half of a quarter is 1/8. Half of 1/8 is the 16th, which is the smallest unit of measurement that we have. Okay. So when I go to the next slide, now we see all 16 lines. When you're looking at a standard ruler, you're going to see 16 lines that are in between. Okay. And take a look what we did. Every single one of those that are the same length, those are 16ths, but we stick with the odd numbers. 1/16, 3/16, 5, 7, 9. No even numbers, none. Anytime we have an even number, it's gotten reduced. Okay. So when you are counting on your ruler, as long as you can count to the number 16, you can easily figure out any of the measurements that are there. Okay. But if you need to cut a measurement in half, okay. So let's say, what if my measurement landed in between the 0 and the 16th? What would that measurement be right in there? Well, that would be a 32nd, 1/32. But for most times, we're not going to go more than a 32nd in this class. Okay. When you get to 64ths, which is 32 times 2, you're splitting hairs. Okay. You're talking really, really small measurements. So when we're looking at our ruler, okay, every time you split a measurement in half, you double the bottom number. So we go from a half to a quarter to 1/8 to a 16th. And then those follow across as odd numbers. Odd numbers go across. All right. So right away, they want to know, how long is this rectangle? Okay. Much like we did in the metrics, they want to know, how long is this particular rectangle? Well, they blow this up so we can look a little closer. Go ahead and pause the video so you can write down what the measurement was. Okay, now we're going to continue on. So when we take a look at how long this rectangle is, all right, we know that it's between 2 and 3. So it's 2 something. Okay. We start counting lines. We got 1, 2. Okay. 2 lines. All right. Doesn't quite get to the third line. Doesn't quite get there. All right. So since I said anything that lands in between these lines, we're going to use a 30-second. Okay. A 30-second. So as we're looking at this number, okay, this would have been 1 30-second. This would have been 3 30-second. And this would have been 5 30-seconds. So the answer that we were looking for on this particular one would be 2 and 5 30-seconds, because we have to split each of those in half. You have to pretend that in between each of these are other lines. All right. And for our class, we're only going up to 30 seconds. We're not going to do anything more than that, because then you're talking splitting of hairs. Okay. Super small measurements. All right. So if you're looking at your standard ruler, okay, imagine splitting those increments in half and then in half again, really, really small. Okay. And you can even go smaller and smaller and smaller. Okay. Up to 128. And, we're not going to do all that. All right. Not in this class. All right. So here they're breaking it down. Okay. They're saying that this is 3/16 because it's the third line. Okay. This is an eighth. Okay. It's the second line, which would be 2/16. 2/16 reduced is 1/8. It lands between those two. All right. So they said it's 5 30-seconds. Okay. As long as you can count to 16, okay, as long as you can count to 16, you're in good shape. Let's go back where they show you the ruler here. Okay. If you're counting lines, much like the metrics, all right, we know there are 16 lines. If it is before the half, you can count up 1 to 7 up to this point. All right. If you know it lands somewhere over here and you're not sure, oh, what does that line mean? How long is that line? That's okay. Okay. Eventually, it'll come to you very quickly and you'll know exactly what all these lines mean. But as first time learners, you don't necessarily know that. Okay. You'll know what the half is and you probably know what a quarter and 3/4 are. And then after that, the lines all blend together. Okay. Until you get really good at this, you got to be able to count to 16. So if I know this is 8 and the measurement lands somewhere over here, I can immediately start counting at 8. I don't have to count 1, 2, 3. You don't have to do that. Okay. Up to 8 is already accounted for you. So if it lands over here on this line, all I would have to do is count 9, 10, because I already know 8 is in the middle. Okay. All right, let's move forward. Two and 5 30-seconds. See if they give you another example here. Okay, so right away they go into what you're going to be doing in the packet. So I'm going to switch back over to Word. We'll take a look at the Word document here. All right. So when we're looking at the Word document, this packet will look very similar to the one you just completed. Okay, so here you have the chart. It's the same chart, but now you'll notice that the ruler is in inches. So you're going to record your measurements. Where are all these landing? Okay, if it doesn't land exactly on one of the lines, remember we're going with the 30-second measurements. Okay, so here we are. You're recording two different numbers. You're going to record your measurement as a fraction, and then you're going to convert that fraction to a decimal. Okay. So you're recording two numbers here. One is a fraction, one is a decimal. Then you're going to do some subtraction. Okay. When you do the subtraction here, okay, say what the difference is. You can do that as a decimal. You don't have to do that as a fraction. All right. Coming down, you're going to do the same chart, but now the chart is asking you for two answers. Okay. So when you do the overall length of this chart, okay, they want to know fraction, decimal, fraction, decimal for every single one of these. You have to record 2 numbers for each one, okay? Coming down, you're going to pick 5 random objects again, okay? So anywhere in the classroom, okay? Is it 5 or 6? 1, 2, 3, 4, 5, 6. So 6 objects you're going to select, all right? You're recording what the object is, what the description of the object. So if I'm going to say electrical socket, height of electrical socket, they want to know the measurement in units, as a fraction, and as a decimal, okay? So the units are inches, and then you're going to record as both a fraction and a decimal, okay? You have one drawing to do here. This is going to get done again on ISO paper. So when you go to do this on ISO paper, instead of coming 2.75 blocks across, you are going to do that in inches, okay? So as you come across, you're not counting blocks. You're actually going to draw this so it is the exact size that they're asking, okay? Use your ruler and actually draw that on ISO paper, all right? That's what we're doing. We're working on measurement. If you have questions, please feel free to reach out, and I will talk to you soon. Good luck, Rovers.